Hello and welcome to your lesson on the Global Atmospheric Circulation Model. I'm Miss Dubas and I'll be taking your lesson today. Please ensure that you've got a pen to write with and a piece of paper, and you've also got a different colour pen so that you're able to mark your work. If you need to go and collect any of those things, that is absolutely fine. Just pause the video and then come back to it when you are ready. Also ensure that you're working somewhere free of distraction and that it's nice and quiet so that you're able to focus on your learning. And whenever you're ready, we can get started. So this lesson is all about the Global Atmospheric Circulation Model. It is one of the most challenging parts of the GCSE, but we're going to work together to make sure that you really understand it. There are 2 lessons on this though. Make sure that you have done both of them because that will help to secure your learning. So air circulates in our atmosphere between high and low pressure belts, and this creates cells in our atmosphere. This also helps to create wind. So we are going to find out how that happens. In order for us to do that, we need to make sure we understand 2 key ideas so that the rest of the model makes sense. So we're going to have a look at idea 1 and we're going to follow that up with a short quiz, and then we're going to look at idea 2 and then we'll follow that up with another short quiz just to make sure we understand them before we move forward. So idea 1 is latitude and hemisphere, and you may have come across those key terms in geography previously. If you haven't, don't worry because we're going to review them here. So this image shows you the major lines of latitude on Earth. So you may recognise some of these lines of latitude already. So latitude is a measure of distance from the equator. So the equator is 0 degrees, and as you move north and as you move south away from the equator, the latitudes increase. So the equator is 0 degrees, and if we look north of the equator, the Tropic of Cancer, 23.5 degrees north, the Arctic Circle, 66.5 degrees north, and finally the North Pole is 90 degrees north. The same occurs in the southern hemisphere. So the equator is 0 degrees, the Tropic of Capricorn, 23.5 degrees south, the Antarctic Circle, 66.5 degrees south, and finally the South Pole at 90 degrees south. So remember that the latitude is a measure of distance from the equator. A fun fact about the equator, it is 40,075 kilometres long. It is the widest part of our Earth. So just a reminder, the North Pole is 90 degrees north and the South Pole is 90 degrees south. This will come in really useful to us later on when we learn more about the model. The term hemisphere then, hemisphere means half of a sphere. So anywhere north of the equator is the northern hemisphere, and anywhere south of the equator is the southern hemisphere. So in order to ensure that you've understood those key ideas we've just reviewed and we've just covered, I'd like you to complete the short quiz on the screen at the moment. So there are 5 questions. What is latitude? What is the latitude of the equator? What is the latitude of the North Pole? Which hemisphere is south of the equator? And for a bonus point, what is the length of the equator? So please can you pause the video and then resume once you are ready to mark your work. So in order to mark your work, please ensure that you have a different coloured pen so that you can see your corrections clearly if you need to add any corrections. And of course, if you've got the answer correct, give yourself a great big tick. So I'm going to reveal the answers and then we're going to mark our work. So what is latitude? It is a measure of distance from the equator. Number 2, what is the latitude of the equator? It's 0 degrees. Number 3, what is the latitude of the North Pole? It's 90 degrees north. Number 4, which hemisphere is south of the equator? That's the southern hemisphere. And number 5, for a bonus point, what is the length of the equator? It's 40,075 kilometres in length. How many did you get right? Did you get 5 out of 5? Brilliant. If you didn't, do not worry at all. Just ensure that you've understood these key ideas before you move forward. If you need to go back and review part of the video, that is absolutely fine. So the second key idea that we need to have clarity around is the difference between low and high air pressure. So we're going to take each in turn to make sure that we fully understand them. So low air pressure occurs when air is warm, less dense, and is ascending or rising away from the surface of the Earth. This air will cool, condense, and form clouds. High air pressure occurs when air is cool, dense, and is descending or sinking towards the surface of the Earth. No clouds will form. So just to be clear, low air pressure occurs when air air is rising away from the surface of the Earth. It can cool, it can condense, it can form cloud, and therefore you get lots of rainfall in areas where there's low pressure. High pressure is the opposite, so air is sinking because it's colder, and therefore it sinks towards the surface of the Earth, and no clouds can form because there's no opportunity for that air to cool and condense and form a cloud. So I always remember the difference between low and high pressure as being high pressure is happy weather when it's sunny and you've got clear skies. And the last thing to remember about this difference between high and low air pressure is this: that wind is actually caused by the movement of air from high pressure to low pressure. So to ensure that we've understood high and low air pressure, I'd like you to decide which of these following statements you think is false. So option 1, high air pressure means cool air is sinking towards the Earth's surface. Option 2, low air pressure is caused by sinking air. Option 3, winds move from areas of high pressure to areas of low pressure. And option 4, low air pressure means warm air is rising away from the Earth's surface. So you need to decide which of these statements is false. Option 1, option 2, option 3, or option 4. If you'd like to pause the video so that you can reread the statements, that's absolutely fine. Or you can revisit the high and low air pressure content from in the video previously if you would like to review the areas first before making your decision. So let's have a look at the answer. Option 2 is the false statement. Low air pressure is caused by sinking air is not true. Low air pressure is actually caused by rising air. If air is sinking, high pressure is occurring. So now that we are clear about what latitude, hemispheres and air pressure mean, we are now going to start to apply that knowledge to global atmospheric circulation. So we're going to be learning about pressure belts, cells and wind. So what is global atmospheric circulation? It's what's occurring in our atmosphere. Air in our atmosphere circulates between high and low pressure belts to create cells, and there are 3 types of cell. There's the Hadley cell, the Ferrel cell, and the polar cell. We're going to focus on the Hadley cell for the rest of this lesson, and we're going to be reviewing the Ferrel cell and the polar cell in our second lesson. I want to draw your attention towards the diagram that you see on the screen. It does look a little bit scary when you first see it. And you'll notice that the Hadley, the Ferrel and the polar cells are all labelled in the northern hemisphere to show their location. This is also mirrored in the southern hemisphere. So in our atmosphere there are 2 Hadley cells, there are 2 Ferrel cells and there are 2 polar cells. You'll also notice on the diagram there are green belts that run across the Earth. And what we're going to do is we're going to zoom in on those a little bit and have a little look at what they actually show us. So at the equator, at 0 degrees, you'll notice that the green belt has got an L written on it. The L means low pressure. That means at the equator, air is warm, it's less dense, it's rising into the atmosphere, it's cooling, condensing and forming cloud. It's low pressure. You'll notice at 30 degrees north and 30 degrees south of the equator, we have high pressure. So air here is sinking towards the Earth's surface. It's cooler, it's denser, it's sinking. You'll notice at 60 degrees north and 60 degrees south, we have low pressure belts again. So that means at 60 degrees north and 60 degrees south of the equator, air is rising because it is warmer, it is less dense, and it is cooling and condensing in the atmosphere to create cloud. At 90 degrees north and 90 degrees south of the equator, we do also get high pressure in those locations. So at the North and South Pole, high pressure is occurring. Air is sinking back towards the Earth because it is cooler and it is denser. One last thing to note about this diagram are the arrows that you see within the blue areas of the diagram. And these show us the surface winds that we find on our planet. And I just want you to notice something about them. We mentioned earlier that air travels from areas of high pressure to areas of low pressure. And if you look at this diagram, you'll see that the surface winds are travelling from areas of high pressure back to areas of low pressure. So let's now take a little look at the Hadley cell in more detail at what's occurring in that area of the atmosphere. So let's take a closer look as to what's happening within the Hadley cell. So the sun's energy is most concentrated or focused at the equator, and this causes air at the equator to become warmer due to this sun's energy. This causes the air to rise because it's become less dense, so it rises into the atmosphere and it creates low pressure. As this air rises, it cools, condenses and forms a cloud, and therefore we've created around the equator a low pressure belt. And this is where we get quite a lot of rainfall, and this is where tropical rainforests are located. As this air continues to rise, it reaches the top of the troposphere, which extends up to about 15 kilometres into the atmosphere. When air reaches the troposphere, or the top of the troposphere, it moves north and south of the equator, cooling further. At 30 degrees north and south of the equator, this air begins to sink back down towards the surface of the Earth because it's now cool and dense. So this creates high pressure. So you'll notice on the diagram at 30 degrees north and 30 degrees south, there are two belts of high pressure. And these latitudes are called horse latitudes if you want to include some challenging language. Areas of high pressure at 30 degrees north and 30 degrees south have very low rainfall, and this is where you'll find desert areas. So you'll also notice on the diagram that there are arrows in the blue area of the diagram that go from the horse latitudes at 30 degrees north and south back towards 0 degrees at the equator. So if you remember, we said that air will travel from high to low pressure. So air from 30 degrees north and 30 degrees south will travel back to the equator at 0 degrees because it's travelling from high to low pressure. So that closes the Hadley-Cell loop. We call these winds that travel back to the equator trade winds. You'll also notice that from 30 degrees north and 30 degrees south, there are winds that are travelling further north and further south, and we call these winds westerlies. So to ensure that you fully understand how air circulates around the Hadley cell, I'd like you to complete the activity that's on the screen. You'll see there's a paragraph, and within the paragraph, there are some brackets with a choice of 2 words. So I would like you to copy and complete the paragraph below by selecting the correct word from the brackets. So you'd need to pause the video, complete the activity, and then resume the video so that we can mark your work. So it's now time to mark your work. So please ensure you've got a different colour pen, and if you've got the answers correct, you can give yourself a tick, and if you need to make any corrections at all, then you can add those in with your different coloured pen. Air circulates around the Hadley cell. Air at the equator warms, becomes less dense, and rises into the atmosphere. Here, it cools and condenses to form clouds. This forms a low pressure belt and an area of high rainfall. As air reaches the top of the troposphere, it moves out to 30 degrees north and 30 degrees south of the equator. Here, the air cools, becomes denser, and sinks. Clouds do not form, resulting in an area of low rainfall. This forms a high pressure belt. Winds that move back towards the equator are called trade winds, and winds that move back towards higher latitudes are called westerlies. The air now moves from high to low pressure. So how did you do? It's quite a tough activity, so very well done for all the efforts that you've put in to completing it. So that brings us to the end of our first global atmospheric circulation model lesson. Remember, there is a second lesson that you need to complete to ensure that you fully understand the full model. You now need to complete the exit quiz just to make sure that you've picked up the key ideas from today. But very, very well done. You might want to summarise maybe 3 things that you've learned from today so far, so that when you undertake the second lesson, you're able to ensure that you secure that learning. But very well done for your efforts. Take care. Bye-bye.